We have a question about an investment account where on the 1st of January 2020, Laura invests P dollars in an account, and we have a nominal annual interest rate of 5.5%, and it's compounded quarterly, which means that 4 times a year the 1 quarter of 5.5% of what's on the account will be added to the account. And we're asked to find how much this grows with every year, because obviously this is a geometric sequence with the common ratio. So we have basically a sequence where the value at the beginning of each year, Pn, equals the initial value, P, times r to the power of n minus 1. But we have, so in this case then, we are after what is r, so we want P1 equals then P times r. But we also know that the future value of an investment equals the present value of the investment times 1 plus r divided by 100k, everything raised to k times n, where k is the number of compound periods per year and n is the number of years. So in our case, after 1 year, we have the future value, which equals to, as I call it above, P1 equals P times 1 plus 5.5 divided 400 raised to the power of 4, because n, the number of years, is 1. And so comparing this one and this one shows that this is the value of r, so we simply push it into our calculator and it turns out to be approximately 1 point, sorry, let's have a look here, 0.56. So this is the ratio with which the investment will grow each year. And then for B, we're told that there are no further changes into the account, that is to say no deposits, no withdrawals, and we want to find in what year the money will be double of what you had before. And so we can use this again. The value at the start of a year equals, of year n, equals the original value times r to the power of n minus 1. And this should, in this case, equal 2 times p. So r to the power of n minus 1 equals 2. This, we know what this is. It's 1.056. And here we should be very, very careful when we solve this to use the full precision of our calculator. That is to say, this value, despite being shown as a rounded off figure, had of course more precision when we calculated it, so we store that in a suitable variable in our calculator and we use that. So to the power of n minus 1 equals 2, and we solve this graphically, I would most likely do, or with the equation solver. We can of course again do it analytically and say that n minus 1 times the logarithm of, I'm going to just write r, that is this value, equals the logarithm of 2. And then, since this is a value we know, this is a value we know or can find out from our calculators, we can solve this for n. Regardless of what we do, we find that n equals 12.7 years. So starting 1st of January 2020, this will happen in the year 2032. A bit after halfway through the year, the investment will have doubled.